Good morning, my dear students. Our chapter number 6 of physics subject is going on, which is the electric circuit. Okay. Yesterday we discussed about potentiometer, principle of potentiometer, and some construction of a potentiometer. Okay, what is potentiometer? A device which is used to measure an unknown potential difference accurately between two terminals of in a electric circuit. That is potentiometer. And a very important principle of potentiometer, in the zero deflection state in galvanometer, unknown electromotive force is equal to the non-electromotive force or potential difference. This is the principle of potentiometer. Today we study applications of a potentiometer. In this sequence, first is determination of internal resistance of a primary cell. Okay, if we have a primary cell, then we determine internal resistance of that cell. Okay, for this, first we draw a circuitry diagram of this application, and I speak its structure construction with the diagram. Okay, so see carefully. Suppose this is the wire of potentiometer AB. Then this wire is connected with a cell. This is a cell and a key and a rheostat in series. This is rheostat RH, this key K1, and this cell, EMF of this cell is EP. This is the primary circuit. Okay, now in secondary circuit we have another cell with unknown internal resistance. Then positive terminal of this cell connect to point A. You learn this thing. Positive terminal of all cells connect to point A. Okay, so this plus minus, and a negative terminal is connected with galvanometer Z, and another terminal of Z is also connected to jockey. This is a jockey J. Okay, and EMF of this cell is E, only E. Now a resistance box, this resistance box and a key K2 connect between the terminal of this cell E. This is the construction and this diagram of a application of potentiometer, which is determination of internal resistance of by the help of a potentiometer. Okay, now we study working. See carefully. Firstly, we close this key K1, and by keeping the key K2 open. Firstly, this only this key K1 is closed. Then in this situation, current flowing through this primary circuit. Okay, then in this situation, this galvanometer shows the deflection. Now by moving this jockey over this wire of potentiometer, in the galvanometer we achieve zero deflection. In zero deflection state, suppose this is the zero deflection state. In this situation, distance between point A and zero deflection point is called balancing length. Suppose this is L1 for first situation. Okay, so if zero deflection state, balancing length is L1 and potential gradient of this potentiometer is X. Then according to principle of potentiometer, what is principle of potentiometer? This is in zero deflection state, the unknown electromotive force is equal to the non-electromotive force or non-potential difference. Okay, so according to this principle, the unknown EMF of this cell E is equals to potential difference between these points A and this J. Here potential gradient is denoted by X and balancing length is L1. Then total, what is potential gradient? Voltage drop per unit length. Voltage drop per unit length. So voltage drop in per total length, so X into L1. This is equation number 1. This is the unknown EMF and this is a known potential difference. Okay, now we close the key K2, this K2, and before this, by applying a resistance capital R, a resistance, removing capital R from this resistance box, and then K2 is closed. Then in this situation, another deflection is produced in this galvanometer. Now again, by moving this jockey, we get zero deflection in this galvanometer, and zero deflection, suppose this is another state Z dash. In this situation, suppose balancing length is L2. Then again, according to principle of potentiometer, now here this circuit is closed. Then this E is equal to the terminal voltage. Okay, so terminal voltage of this cell V is equals to, again by the principle of potentiometer, multiple of a potential gradient into balancing length. This is the voltage drop per unit length and this is total length. So total voltage drop on this length is equal to X into L2, which is equal to terminal voltage of that cell. This equation number 2. Okay. Now suppose internal resistance of this cell is equals to R and the current flowing through this resistance capital R is I. Current flowing through this resistance capital R is capital I. Then we studied in previous chapter relation between EMF and terminal voltage and internal resistance, which is E is equals to V plus IR. From this equation, IR is equals to E minus V, and so internal resistance R is equals to E minus V upon I. Here I is current flowing through this resistance capital R. Then according to Ohm's law, voltage drop across the end of this resistance capital R, V is equals to IR. Okay, so put the value of I is equals to V upon R in this equation. Then R is equals to E minus V upon V into R. Now from equation 1 and 2, put the value of E and V in this equation. Then R is equals to X into L1 minus X into L2 upon X into L2 multiply R. Now take X common. on upper part, then x to x cancel out, then we get R is equals to L1 minus L2 upon L2 into R. This is the internal resistance of a primary cell. Okay. In this equation, R is the resistance which is we remove from the resistance box. L1 balancing length of primary circuit, L2 balancing length of balancing L1 is the balancing length of a first condition. It means open circuit, and L2 is the balancing length in a closed circuit when this K2 is closed. Okay, now taking different values of this R from this resistance box, we find different values of L2, and by this we find that different values of internal resistance capital R. Okay, this is the internal resistance of a primary cell. Now our next application is, this first application is very important for our annual examination, so learn carefully and remember this. Okay, now next is comparison of electromotive force of two primary cells. Okay, again construction of this application. Now again I speak its structure, its construction with the diagram. So see carefully. Suppose this is a wire of a potentiometer AB. This is connected in primary circuit with a cell, a key and a rheostat RH in series like this. This is RH, this K, and positive negative this cell EP, EMF of this cell. Now in secondary circuit, the positive terminals of all cells connected to this point A. So here the positive terminal of two cells, first is E1 and second is E2. Then positive terminals of the cells E1 and E2 connect with the point A. Okay, and negative terminals connect with the terminal X and Z. This is a two-way key. Here, this is a two-way key. In two-way key, three terminals are exist, and one-way key only two terminals. One is positive and one is one is input and one is output in one-way key. This is our daily life switch. One-way key, and this is a two-way key. In this key, two terminals are input and one is output. Okay, if we plug a dot between these, then these are working, and if a dot insert between the two terminals, then these are in a working. Okay, so this is a two-way key. This is a two-way key, this X, this Y, and this Z. Okay, so negative terminals of these cells is connect to terminal X and Z of two-way key, and terminal Y of this two-way key is connected to galvanometer Z, and this galvanometer is also connect a jockey. This is jockey Z. Okay, this suppose this E1 and this is E2. This is the construction of this. Now working. Firstly, we close this key K. Then in this situation, current flowing through the primary circuit. Now a dot plug insert between the terminal X and Y. Insert a dot between the X and Y terminals of this two-way key. Then in this situation, this cell even in working. In this condition, this galvanometer shows the deflection. Now, by moving the jockey on this wire, we determine balancing length for this cell of EMF E1. And in this condition, balancing length, suppose balancing length is L1. Balancing length is L1 for cell of EMF E1, and potential gradient of potentiometer is X. Then according to principle of potentiometer, what is according principle of potentiometer? In zero deflection state in galvanometer, the value of unknown EMF is equal to the value of known EMF or known potential difference. Okay, so value of E1 is equals to, according to principle of potentiometer, this is the potential gradient, this equal to the voltage drop per unit length, and this is total length, so total voltage drop is X into L1. This equation number 1. Now, by removing this dot from X and Y, and this plug, this dot inserted between Y and Z, then in this situation, this cell of EMF E2 in working, then in this condition, the balancing length of cell of EMF E2, suppose this is another situation Z dash and balancing length is L2. Then in this situation, E2, again according to principle of potentiometer, E2 is equals to multiple of potential gradient into balancing length. This is the E2, unknown EMF of this cell. From equation 1 and 2, E1 upon E2 is equals to X into L1 upon X into L. X to X cancel out, then E1 upon E2 is equals to L1 upon L2. Okay. This is the ratio of a potential EMF of a cells, and according to this, the ratio of EMF of the cells is equal to the ratio of corresponding to the balancing length. Okay, in this experiment, we find different values of L1 and L2. Different values of L1 and L2 by the different values of RH. Okay, in this situation, in different L1, for different L1 and L2, we determine E1 over E2, different values of E1 over E2, and we find the average value of E1 and E2s. Okay, so we determine the ratio of EMF of cells, and we can say this is the we compare the EMF of two primary cells. Okay students, these are the important applications. First application is very important, so learn carefully and read it very carefully. Okay, thank you.